Our focus now is on the efficacy of the estimator. How well does the relative frequency of successes in a random sample actually approximate a true underlying population proportion? But before we dive into the technicalities, it would be well to step back and take a look at what underlies all our calculations, and that is the idea of a random sample. I will phrase our discussion to follow in the context of polls, but what I'm going to say is going to be valid for any random sample generated from any chance experiment. Now, there is an art to a random sample. What is the first step in the idea of a random sample? Well, the first step is to construct a sequence of trials, and there are two key features. One, the idea of independence, and two, the idea that the trials are all from an underlying chance experiment. Let us take these one at a time. First, the central and key idea of independence. This is the idea that runs a thread through all of the theory of chance. The key principle is cane of independence. What does independence mean? At its foundational level, from a purely formal point of view, independence implies a rule of products. Formally, that when one looks at a sample generated by independent trials, then probabilities are obtained by multiplying raw probabilities for each trial. What does this mean in the context of a poll? Now, for a poll, we have some underlying population, fixed, and for the purposes of the poll, immutable, it does not change. And sampling implies that we do it fairly, that every member of the population has an equal chance of being selected in any given trial. In other words, a member of the population is chosen uniformly at random. But that is not all. The moment an individual is selected and queried or looked at, it is imperative from the formal point of view that that individual is replaced in the population before an independent second trial is conducted. In other words, sampling is with replacement. The listener can easily see why the replacement idea is important, especially when one considers small populations. Let's say one has a population of 3 people. The moment one queries something to one person, if that person isn't replaced in the population, the next sample element is drawn from a population of 2 people. We have changed the underlying chance conditions. The population has changed from trial to trial. Now, admittedly, when populations are large, this effect becomes vanishingly small. Say if a population has got size of 100 million, then it makes little matter whether one member is replaced or not, especially in the context of relatively small samples of hundreds or thousands. But this is an important guiding principle to be kept in mind. Sampling has to be done with replacement and uniformly from the entire population. So at heart, the idea of independence engenders a product space and a product probability measure where probabilities are obtained by multiplying. If the listener will cast her mind back to Tableau 10, and when we looked at the construction of the binomial distribution, she will realize that at the heart of the construction was a simple multiplication of Bernoulli probabilities. So this is the first key central idea in the notion of a random sample. In an application, the user will be well advised to look at the provenances of a sample before doing any analysis. If somebody reports and says, I've got such and such sample, it would be well to cast an eye at the conditions under which the sample was generated. In practice, of course, we deviate from these assumptions, these sterile and beautiful assumptions of independence in various ways. The question then is, how much of an artifact do we introduce in practice? And to the extent that the assumption of independence is violated, to that extent our conclusions are suspect. So this is our first key tenet, independence. But there is a second tenet, and that is that the sampling is done by sampling consistently from some underlying chance experiment, a target experiment which does not change from sample point to sample point. Now, it is very easy to introduce bias into an otherwise honest experiment. The sampling might be done independently, but the target experiment might well not be the one that we think we have in mind. Bias may be conscious or unconscious. When it's conscious, of course, this is the stock in trade of the unscrupulous pollster. Bias can arise in several different flavors, and it is again important to understand the nuances of how uncertainties and biases can creep into these samples. The first example of bias is when, in sampling from a population, there is a bias in selection. Now, let me give you a couple of examples. In an earlier generation, genders were very firmly aligned with different roles in society. Right? So, for example, in the early part of the 20th century, in many societies, men worked outside the home, women stayed at home and took care of the household. Now imagine a poll conducted, let's say, in the 1950s when telephones were just beginning to become widespread. And a telephone poll is conducted, and the pollster says, well, let me call homes at, let's say, noon or 1 p.m. Would there be a problem in conducting such a poll? Assuming, of course, that the numbers are chosen independently or as close to independently as we can manage, nonetheless, it is clear that a selection bias is introduced. Because who is at home in the middle of the day? Well, the homemaker. Even if the poll is conducted independently, the sample then reflects that percent of the population who are at home in the middle of the day. That percentage of the population, while an honest accounting for that subgroup, may or may not represent the population at large. And so here's an example of a selection bias that has insidiously crept into the sampling process. Here's another historical example. The year was 1936, and this was a year of a US presidential election. The two primary candidates were a Democrat, Franklin Delano Roosevelt, on the one hand, and a little-known Republican named Alf Landon on the other. And they were contesting this election. History buffs might recall that this was the time of the Great Depression. Right? The economies were plunged into chaos. Families were thrown into straits. Now, in this election, of course, there was intense interest in who was going to be the likely winner, because that was going to likely determine the policy for the country going forward. A highly read magazine, the Literary Digest at that time, decided to conduct a poll on who the likely winner of that presidential election was. They sent out 10 million questionnaires, received 2 million questionnaires back, and concluded that the Republican Alf Landon was going to win in a landslide. Now, the US political election system is a bit arcane. It's a winner-take-all system, for those who don't understand it, where each state votes and the majority vote determines who wins that state. Each state then contributes a certain number of what are called electoral college votes, and in 1936, there were 531 electoral college votes available, and the presidential candidate who wins the majority of those wins the election. The Literary Digest predicted that Landon was going to win 360 of the 531 electoral college votes on offer. this is a landslide. Of course, history showed they were wrong. Roosevelt won, and won convincingly. In fact, Roosevelt won by one of the largest margins in history. This had been predicted by a young man named George Gallup, who had conducted a poll on 10,000 individuals. Not very large, is it, compared to 10 million. And he observed that based on the polling numbers, he predicted that all but a small handful of 6 electoral college votes would go Roosevelt's way. In other words, a diametrically opposed prediction. And he was right. Now, why would a poll involving tens of thousands trump a poll involving millions? The answer, of course, resides in an insidious bias that had not been factored in by Literary Digest. It turns out that the majority of the readers of Literary Digest were in rural communities. And then, in the United States, as now, rural communities tend to vote strongly Republican. And therefore, the Literary Digest reported an accurate estimate, but for rural communities. Of course, but rural communities do not comprise the entirety of the country. The Gallup poll, on the other hand, looked at the entire country in fair and just proportion, and thereby came up with a much more accurate estimate. Right? Of course, this was then the origins of the Gallup organization and the prevalent Gallup polls of today. So, selection bias is a critical and important thing to look at. When one has a sample, one should cast an eye and say, was this sample taken from the entire population uniformly, or was there some kind of selection bias which focused on a subgroup of the population? A second idea of bias comes about because folks are impatient. Okay, and this is the issue of non-response, or what is also called refusal bias. The listener today is well aware with the common practice of calls coming in to solicit opinions, to sell products. Right? I am a probabilist, but I must confess that when I get home late in the evening and I'm ready for my dinner, and I get a phone call from somebody who wants my opinion on something or the other, in principle, as a good probabilist, I should probably answer so that their sample is unbiased and representative. In practice, I end up saying, no, I don't wish to answer, and I hang up. Here's an example of a refusal bias. This is very difficult to combat, you see, because people naturally value their time and don't want to spend the time answering a stranger's questions. But the moment one refuses, then implicit here is that the sample that is actually obtained is obtained from that subportion of the population who are willing to answer questions. In other words, this is a coalition of the willing. To the extent that that subgroup is representative of the entire population or not representative, you'll find that the sample is representative of the whole population or not. Okay, and this is very, very difficult to combat. Still, another area of bias arises in the wording of the questions. It's a question of phrasing. As I've mentioned, this can be conscious or unconscious, but words are powerful. They convey meaning, and if one uses them incautiously, then what is understood by the listener may be very different from what is intended by the speaker. Right. Let me give you an example, not entirely hypothetical, about how an unscrupulous pollster can shade a poll in any direction she wishes. Right. Imagine that there's a country where at some point in time a law providing health care to retired citizens has been provided. In other words, this is a senior citizen benefit, which allows them to have health benefits from the government after they retire. Suppose this is in place, but there's no such law for the general population. Imagine then that an enterprising leader decides that he wants to provide a law which provides a blanket coverage of insurance for the entire population. Now, good people can debate whether this is a good idea or a bad idea. But let's say we want to get the sentiments of the population on whether this is a good idea or a bad idea. Here are a couple of questions one could pose to the population. Let us say that the existing law, which provides health care for seniors, has been working for many years and has been working well. Suppose one asks a respondent, would we want our children to have the same health care benefits that our parents do? Now, naturally, when one poses a question like this, we all want good things for our children, and therefore, the tendency is to say, oh yes, of course. But suppose one were to phrase the question in the following way. Do you want a nameless bureaucrat to control your health care? Of course, the way the question is worded is extraordinarily pejorative. It feels very bad. You say, certainly not. I want to be in control of my own destiny. But at its heart, both questions touch upon a common underlying structure. The posited health care benefits that the seniors are receiving are provided by the government. It's a government entity. And in both cases, we are referring to something which has been provided by the government. But depending on how we phrase the question, we can elicit very different responses from the same person. And so, phrasing is important. In a good poll, the pollster will make an effort to be completely unbiased and present questions raw without tilting it in one direction or the other. When one evaluates a poll, one should always look at this issue. Right? Of course, you see, when one is given data, we have very little control over the data. We have what it is. But if we want to begin an analysis on it, we should always begin with the question of, are the data sound? Is this really a random sample from the experiment I had in mind? Is independence approximately visible? Is there bias? Now, with this for background, let us now return to the question of the poll.